Mrs. Cribb, and this is the Common Errors for Chapter 9B's quiz. And so I went and did the grading and checked everything, and we're going to go over the things that people miss the most. And if I cough during this presentation, I'm sorry, I'm struggling a little bit with my voice today. Okay, here's the first one. I'm going to rewrite the equation, and then we're going to go forward from there because you might not be able to see it. We're going to use the exact same equation for each one of these questions. So here we are. Well, you can see it right here. Copper 2 chloride and sodium nitrate react to form copper 2 nitrate and sodium chloride. So the question is, first of all, we should always check to see if it's balanced. So we have 1 copper and 1 copper, 2 chlorines and 2 chlorines, 2 sodiums and 2 sodiums, and 1 nitrate and 2 nitrates. Nope, 2 nitrates and 2 nitrates. Okay, yes, it's balanced. If it wasn't, the first thing you have to do is balance the equation. Now, before I do the work on this question, I'm going to go ahead and write out the pathway, okay? And I want you to write the pathway because most of the errors can be avoided if you will follow the path. So we have the mass of A goes to the moles of A using the ratio, with the molar ratio, to the moles of B, to the mass of B, and then you could turn moles into atoms or molecules. And you could also get to moles from atoms or molecules. Okay, now in this case, we're going to identify where we are. So we have 18.8 grams of sodium nitrate. So I got to find sodium nitrate. This is it, sodium nitrate. Sodium, and that's the nitrate ion. So 18.8 grams. How many grams of copper 2 chloride? All right, so how many grams of copper 2 chloride? Well, that's this here. How many grams? One common error was people did not write the unit with their question mark or what was given. And so they didn't know where to start. The unit helps you to know where to start. Now first of all, this is molecule A. Sorry, this is molecule B. Molecule B is always the question. And so that was a common error. People labeled A and B backwards. Molecule B is always the one that we have the question about. Molecule A is the one we know about. All right, so here we're starting with grams right there of molecule A. That means this is where we're starting. We're starting with 18.8 grams. And I want to know the grams of molecule B, so that's what we're going to end. Now we need to use the molar mass of A and the molar mass of B. Avogadro's number goes here, Avogadro's number goes there, and ratio is B over A. All right, this tells you the pathway, tells you exactly what you need to do. You need to follow the path in order to know how to solve this equation. So we're going to always start with the number given in the problem. So we're given 18.8 grams, 18.8 grams of sodium nitrate. Okay, never start with a conversion factor. And so, okay, that's where I am. And to go to in order to get to the new molecule, I have to turn it into moles. I have to go through each one of these steps. So here's my first step. Go to moles. That means I need the molar mass of molecule A. This is molecule A. This is molecule A. I need the molar mass of this molecule. That's what has to go here. I had a few people put the molar mass of B down here. Well, we don't need it yet. We need the molar mass of sodium nitrate. So I'm going to calculate the molar mass of sodium nitrate for you. Before I do that, though, I want you to look at this. Notice that there's a 2 in front. You do not use that 2 to calculate molar mass. The coefficients are only used for the ratio. So I'm going to need a sodium, a nitrogen, oxygen. I need 1 sodium. There's only 1 sodium in that molecule, 1 nitrogen in that molecule, and 3 oxygens in that molecule. Do not multiply those things by 2. The 2 is used in the ratio. Molar mass means so molar mass, MM, is the mass of 1 mole. Mass of 1 mole. So I'm going to multiply these by their molar masses off the periodic chart. So 16, nitrogen is 14.01, and sodium is 22.99. Here it is, 22.99. Make sure you're writing the correct numbers down. Transcription errors will lose you points. Not a lot, but some. All right, you have to multiply 3 times 16, and then we add it all up. I'm going to put the total there for you. See, 3 times 16 is 48. Then we have the 14 and the 22.99. We get this number. This is the molar mass of molecule A. And remember that this line is this line. Okay, so I can either put 85.00 grams on top, and I'm going to write that up there for a minute, and 1 mole on the bottom. But if I do that, I should see right away that the grams don't cancel. Grams and grams don't cancel. If you have them both on the top, they're not going to cancel with each other. That means this is upside down. I need to put the 1 mole on top and the 85.00 grams on the bottom. So let me turn that back upside down. All right, 1 mole on the top and 85.00, 2 decimal places, grams. Now I can cancel out the units. Grams cancels with grams. And that makes sense because I'm trying to go, look, I'm going from mass to moles. So I should have moles on the top. So that's the first step. All right, now I'm going to go for the next step. The next step then is to go from moles of A to moles of B using the molar ratio, the B over A. All right, this is another common error. The ratio comes from the coefficients, the numbers in front. So this is molecule B, and it has a 1 in front. We assume it. So 1 mole of copper 2 chloride. And this is molecule A, and there are 2 moles of it. In the balanced equation, you go right back to the balanced equation. These numbers come straight from the balanced equation. I didn't pick them from any place else. Notice that this number 2 is this number 2. This number 1 is this number 1. All right, that's the ratio, and I can cancel things out again. This is when I know I've changed over to the new molecule. Some people kept skipping this step, and then that means they never got to the new molecule. So when they did the mass, they had the mass of the wrong molecule up there. Sodium nitrate, 1 mole. Now I have moles of my B. That's molecule B, and if I only asked you for moles, you could stop. But I didn't. I asked you for mass. So you have to go again to one more step. So you go from moles of B to mass of B using the molar mass of molecule B. So now I need the molar mass of molecule B. That's molecule B. That's molecule B. I need the molar mass of copper 2 chloride. So copper and chlorine, 2 times 35.45 and 1 times whatever copper is. I'm going to look at the periodic table up here. And look, this is 35.45 for chlorine. Copper is 63.55. 63.55. Okay? All right, this is 70.90 and 63.55. Add it together, and it's going to give me the molar mass of copper 2 chloride. It's 134.45. I think it might have been 0.44 on the quiz because the periodic table had a slightly different number for this one. But again, that blue line is this line. And this time, notice the moles are on the top here. So I need the moles to be on the bottom down here. Normally it's top, then bottom, top, then bottom, top, then bottom. So I need 1 mole on the bottom, 134.45 grams on the top. And you can cancel the units again. 1 mole cancels with 1 mole. And the units I have left are what? Grams of copper 2 chloride. Well, what was the question? There it is, grams of copper 2 chloride. So I didn't cancel out the units. I have the units I need. I canceled the units that I didn't need. So now we just got to put it in our calculator. My calculator, I get 14.868. The last step is to check our sig figs. We have 3 significant figures. So I need 3 here. 1, 2, 3. I look at the next number. It causes the 8 to round up. So it's 14.9 grams of copper 2 chloride. And that's the answer. I made sure I answered the question with the right unit. The right unit is there. All the other units canceled. All right, let's do the next one. Use the same reaction. So I'm going to write the reaction again, just so we can mark it up. Copper 2 chloride plus 2 moles of sodium nitrate gives you 1 mole of copper 2 nitrate plus 2 moles of sodium chloride. Okay? All right, same reaction. How many moles of sodium chloride? So, question mark, moles this time. Produced from 54.3 grams of sodium nitrate. 54.3 grams of sodium nitrate. All right, so let's mark it up. Let's mark it as A and B. B is always the question. So remember that. B is the question. A is what I already know. Okay, A is what I know. So we've labeled the molecules A and B now. So let's go ahead and write out the path again. I should have done that while I had it paused. But you should get to where you can do this super fast. Okay, mass of B, B over A. Okay, molar mass of A, molar mass of B. I didn't put the molecules there because that's not the question. This is the question this time. The question is only asking for moles, which means I only have to stop right here. I want the moles of B. I want the moles of B. And then I start with mass of A, so I'm starting here. So first thing I need to do is from mass to moles of A, using the molar mass of A. So start with what you know again, 54.3 grams of sodium nitrate. Okay? Now I need the molar mass, and I've already calculated it right there. So we're going to use the same molar mass. And the grams of it has to be on the bottom again because I need it to cancel. Because I want moles. I'm going to moles. So I want moles on the top. I want to cancel out the mass. So now the grams cancel. And now I have moles of molecule A. But I want moles of B, so I need the molar ratio B over A. So here, this is where I used the molar mass of molecule A. Remember again, the molar mass does not include the ratio. The ratio, the coefficients are where the ratio is. So there are 2 and 2, and it's always B over A. So 2 moles of sodium chloride. That's molecule B. There's the 2, and it's sodium chloride. And over 2 moles, that's molecule A of sodium nitrate. Yes, you have to write the molecule with the moles. Now cancel out. Sodium nitrate is gone. Moles are gone. That's how I know I went to the right molecule. Now in this case, the 2's can cancel because, math. 2 divided by 2 is 1. All right, this time I'm just going to do the math here. 54.3 divided by 85 grams and ends up being 0.6388 moles. All right, now check sig figs. 3 significant figures, 1, 2, 3. Leading zeros are losers. Okay, so 1, 2, 3, 0.639 moles of sodium chloride. Did I answer the question? How many moles of sodium chloride? Yes, I did. And I have the correct number of sig figs. So follow the path and you'll not make any mistakes. Be careful with your sig figs. Let's move on to the next question. All right, I'm going to stop at this time and write the pathway for you. I wrote the path and I rewrote the equation. So I added in the path this time the molecules of A using the Avogadro's number and the molecules of B or the atoms. Because we're going to need to realize that the only way to do stoichiometry is to get to moles. Moles is the thing that gets you across the ratio bridge to get you to the new molecule. All right, how many moles of copper 2 chloride? There's your question. This is copper 2 chloride, and you have to write the unit because I didn't ask for grams this time. I asked for moles, so that means you need to know where in the pathway to stop. Are needed to produce 35.89 moles of sodium chloride. Again, you need the unit to know where to begin. So this is molecule A because molecule B is the question molecule. This is molecule B. So where are we starting this time? we have moles of A right here. I don't even need the molar mass of A this time. I just need the number of moles. So we start with 35.89 moles of sodium chloride. See, I didn't even have to calculate the molar mass. I need the ratio B over A. That's what I need next. The ratio B over A. And what's the question? The question is moles of B. I'm not going to need the molar mass of B either. I only need the ratio this time. So what's the ratio? Well, it comes from the coefficients, and it's B over A. So molecule B has 1 mole of copper 2 chloride, and the coefficient of 2 moles of sodium chloride, and that is the only thing I need. This is a simple question. I can cancel out moles of sodium chloride, and I have moles of copper 2 chloride, which is my question. So it's just 35.89 divided by 2, which is 17.945. And then I look at significant figures. There are 4 sig figs, 1, 2, 3, 4 sig figs. That 5 causes the 4 to round up. 17.95 moles didn't cancel of copper 2 chloride. All right, so you see the pathway helped me realize I didn't need some things. All right, let's do the next question. We're going to need the same pathway and the same reaction. I'm going to write them in. So I wrote the pathway again, and here's the question. How many moles of sodium nitrate? This is sodium nitrate. NO3 is nitrate. Question mark, moles. Are needed to produce 456 grams of copper 2 nitrate. This is copper 2 nitrate. 456 grams. All right, we're going to label the question. B is always the question. A is always the part you know. So you start with what you know, 456 grams of copper 2 nitrate. Now let's find where we are starting on the pathway. We have grams. That means we're starting here, the mass of A. And it wants moles of B. So I'm going to go to here. I am not going to need the molar mass of B. I need the molar mass of A though, because I have to turn mass to moles. And the only way to get there is to use the molar mass of molecule A. So I need the molar mass of copper 2 nitrate. So that's going to be copper, nitrogen, and oxygen. This 2 makes us have 2 nitrogens, and 2 times 3 is 6 oxygens. Multiply them by their molar mass from the periodic chart, and I don't know copper, so I'm going to look it up. Go way up to the top here. Find 63.55. We used it before. 63.55. All right. So this is 28.02. And what is 6 times 16? 96.00. Add all these together. So 96 plus 28.02 plus 63.55 is 187.57. And it's grams in every 1 mole. This is the molar mass of A. This is the line. That is this line. And then I have to put it so that grams in the top here, so I need grams down at the bottom. So that means I'm going to put the 187.57 at the bottom and the 1 mole at the top, which is great because I need to get to moles anyway. I need to make sure it's in moles. Okay, so that's that step. Now we need to go from moles to moles using the ratio. So I need the B over A. This is molecule B, and there are two moles of B in the equation. So in the balanced equation. So B goes on top. 2 moles of sodium nitrate. This is molecule A. That's on the bottom. There's 1 mole. 1 mole of copper 2 chloride, or sorry, copper 2 nitrate. Cancel units. Copper 2 nitrate can now cancel with copper 2 nitrate. 1 mole can cancel with 1 mole. So I have moles of sodium nitrate. That's what I want. I want moles of molecule B, which is sodium nitrate. So it's just 456 divided by 187.57 times 2. So 4.8621. The last step is check sig figs. 3 sig figs. So I need 1, 2, 3 sig figs. So this 4.86 moles didn't cancel, and sodium nitrate didn't cancel. There's your answer. Followed the path, and I didn't make any mistakes. Okay, one more. I think, no, 2 more. How many molecules of copper 2 nitrate are produced? So it's the same, we're using the same equation over and over again for simplicity, and because I don't want to have to recalculate some things. All right, so I'm just rewriting the equation, and we need to look, I'll use the pathway before. How many molecules of copper 2 nitrate? So this time I don't want moles, I want molecules. Are produced from 2.7 grams of copper 2 chloride. 2.7 grams. So this is molecule A, this is molecule B. I put the pathway back up there, so let's figure out where we are on the path. We are starting with A and mass, so we're here. And we need to know molecules of B, so we need to go here. We're not going to need the molar mass of molecule B. We're going to need to go from mass to moles of A using the molar mass of A. So 2.7 grams of copper 2 chloride. And so I need the molar mass of A. And I think I've calculated the molar mass of copper 2 chloride already. Let me see if I can find it up here so I don't have to do it again. Copper 2 chloride, there it is, 134.45 grams per mole. 134.45 grams per mole. So 1 mole is 134.45 grams. If I didn't have it calculated out already, I'd have to do it. I put it in this way so the grams will cancel. So that gets me to the moles of A. And then I need to go to the moles of B using B over A ratio. B over A. This is molecule B. And there's 1 mole of it. So 1 mole of copper 2 nitrate for every 1 mole of copper 2 chloride. And you have to show this ratio because you have to show you changed molecules. Copper 2 chloride cancels, moles cancel. Now I have moles of this. So what's the question? Where do I go now? I have to get not to molar mass, not to the mass of B, but the molecules of B. So I need Avogadro's number. Okay, that's 6.022 times 10 to the 23rd molecules is 1 mole. So I have to use the correct conversion factor so the 1 mole part will cancel. That means I need to put the 1 mole on the bottom and 6.022 times 10 to the 23rd molecules on the top. Okay, now I can cancel my units. Moles and moles cancel. I have molecules of CuNO3 And so now I'm going to pull up my calculator this time so you can watch me put it into the calculator. Because the order of operation becomes very important with all of this, but particularly when you're using scientific notation. So it's 2.7 divided by 134.45, and then times, because Avogadro's number is at the top here, 6.022. You need to use this second function. You need to use the double E, which is where the comma is, 23, enter. So 1.209 times 10 to the 22nd. See the E22, that means times 10 to the 22nd. Don't forget this part of the answer. That is another common error. People are only going to give me this portion, and they're forgetting to put times 10 to the 22. So 1.209 times 10 to the 22, and then we check for sig figs. 2 sig figs, 2 sig figs, 1.2 times 10 to the 22 molecules. Molecules of Cu NO3, 2. That didn't cancel, and molecules didn't cancel. All right, there's one more question, because I threw it in here. It wasn't on the quiz, but it could come up. And I just want to make sure that you're understanding. So I'm going to write the path one more time. Here's the path one more time. And I should have written the equation out, so I should have memorized it by now. Let's see, CuCl2 plus 2 NaNO3s yields CuNO3 plus, I think, 2 NaCls, 2 sodium chlorides. Okay. All right. Let's look at it one more time. How many molecules of copper 2 chloride? This is copper 2 chloride, chlorine and copper in it. How many molecules, not moles, are needed to produce sodium chloride 3.4 times 10 to the 45th power molecules of sodium chloride? All right, let's label our A's and B's. B is always the question. B is always the question. A is always what you know. All right, where are we starting with A this time then? Molecule A, we don't have the mass of A. We have the molecule count of A. So we're here. So to get to B, which is the molecules of B, we want to get to here. So I'm not going to need the molar mass of B. I'm not going to need the molar mass of A. I'm going to go from molecules to moles using Avogadro's number. So I start with what I know. 3.4 times 10 to the 45th molecules of sodium chloride. I need Avogadro's number. Well, what is that? I'm turning it into moles. So that means I'm going to have the 1 mole portion on top and Avogadro's number on the bottom. Times 10 to the 23rd molecules. That's how many molecules are in 1 mole. Cancel my units. Molecules cancel. So now I have moles of A. I have moles of sodium chloride, and I want to go to moles of B, so I still have to use that molar ratio. You're always going to need that. B over A. All right, so molecule B, I have 1 mole of copper 2 chloride. Molecule A, I have 2 of them. 2 moles of sodium chloride. All right, so you see, there's the 2 right there. 1 right there. All right, that's the ratio. I can cancel out some more stuff now. Sodium chloride cancels with sodium, top, bottom. Moles cancel with moles. Now I have moles of molecule B. But I need to get to molecules, so I got to use Avogadro's number one more time. All right, this time I want molecules, so I need the 6.022 times 10 to the 23rd molecules on the top. And it's always in 1 mole. That's how many things are in 1 mole all the time. What else can I cancel? Well, now I can cancel 1 mole. And in this case, I can cancel this number with this one, because 1's in the numerator and 1's in the denominator. So it's just this number divided by 2. It's the only thing not canceled, and that's the units. That many molecules. All right, so I'm going to pull it up on my calculator. Again, turn it on. We have 3.4, second function. There's the double E, 45. Enter. I don't have to divide by this number because it's already got canceled. I just have to divide by 2. Divide by 2. Enter. Now let's scooch it over. Yep, see, that's the only other number. So it's 1.7 times 10 to the 45th. 1.7 times 10 to the 45th molecules of copper 2 chloride. That unit didn't cancel. That unit didn't cancel. Molecules of copper 2 chloride, that's what I was asked. That's all there is to it. Be very careful with your rounding and your units. Your units have to be in their steps. Okay, I hope this helps, and I will see you soon.